These ML question stumps 80% of candidates. What are transformers? Answer: transformers are a type of electrical device that transfers electrical energy from one circuit to another through electromagnetic induction. They are commonly used to step up or step down alternating current AC voltage levels, allowing for efficient transmission and distribution of electrical power over long distances. In simple terms, transformers are devices that change the voltage of an electrical current, making it possible to transmit power safely and efficiently over long distances. They are widely used in power generation, transmission, and distribution systems, as well as in many other applications such as in electrical devices, appliances, and equipment. What is a deep belief network (DBN), and how does it differ from a traditional neural network? Answer: a deep belief network (DBN) is a type of neural network that is composed of multiple layers of restricted Boltzmann machines (RBM). Unlike traditional neural networks, which are trained using backpropagation, DBN are trained using an unsupervised learning algorithm called contrastive divergent CD. This allows DBN to learn complex hierarchical representations of the input data, which can be used for tasks such as image recognition and speech recognition. The key difference between DBN and traditional neural networks is that DBN are able to learn multiple levels of abstraction from the input data, allowing them to capture more nuanced and detailed patterns. This is achieved through the use of multiple layers of RBM, which are trained to learn increasingly abstract representations of the input data. Overall, DBN are a powerful tool for modeling complex data distributions and can be used for a wide range of applications. What is the main difference between shallow networks and deep networks in terms of their architecture and capabilities? Answer: the main difference between shallow networks and deep networks is the number of hidden layers they have. Shallow networks have only one hidden layer, while deep networks have multiple hidden layers. This difference affects their capabilities, with shallow networks being better suited for simple tasks and deep networks being able to learn more complex and nuanced relationships in the data. Deep networks are also more computationally expensive and harder to train than shallow networks. What is a deep learning framework? Answer: a deep learning framework is a collection of software libraries and tools that provide programmers with a better way to develop and train deep learning models. It offers a high-level interface for creating and training deep neural networks, as well as lower-level abstractions for implementing special functions and topologies. This allows developers to focus on building and improving their models, rather than worrying about the underlying technical details. Some popular deep learning frameworks include TensorFlow, PyTorch, Keras, CAF, and MXNet. What do you mean by vanishing or exploding gradient descent problem in deep neural networks? Answer: in deep neural networks, the vanishing or exploding gradient descent problem occurs when the gradients of the cost function with respect to the model's parameters become either very small vanishing or very large exploding during training. This can cause the model to perform poorly or fail to converge to a reasonable solution. Vanishing gradients can lead to the model missing important aspects of the data, while exploding gradients can cause the model to surpass its optimal levels and fail to converge. Techniques such as weight initialization, normalization methods, and careful selection of activation functions can be used to mitigate these problems. You're watching this to grow, so take it one step further, challenge yourself at MLQsafe.com. Practice real questions, see where you stand, and keep getting better. One quiz at a time. Now let's get back to the next question. What is gradient clipping? Answer: gradient clipping is a technique used to prevent the exploding gradient problem during the training of deep neural networks. It involves rescaling the gradient when its norm exceeds a certain threshold. This ensures that the gradients don't become too large and prevent the model from diverging. The idea is to clip the gradient, i.e., set a maximum value for the norm of the gradient so that it doesn't become too large during the training process. This technique is commonly used in recurrent neural networks RNN to prevent the exploding gradient problem. What is momentum optimization in deep learning, and how does it help the optimization process? Answer: momentum optimization is a method that accelerates the optimization process of a deep learning model by modifying the standard gradient descent technique. It does this by incorporating the accumulated gradient from earlier iterations, known as a momentum, into the current update of the model's parameters. This allows the model to keep moving in the same direction even when the current gradient is pointing in a different direction, which helps to prevent the model from getting stuck in local minima and enables faster convergence. The momentum term is a hyperparameter that determines the amount of the previous gradient to be integrated into the current update, with low values making the model more sensitive to changes in gradient direction and high values keeping the model moving in the same direction for longer periods of time. How are weights initialized in neural networks? Answer: weights in neural networks can be initialized in 4 ways: zero initialization, random initialization, savior initialization, and e-initialization. Zero initialization sets all weights to 0, which can cause slow convergence or prevent learning. Random initialization assigns random values to weights, which can lead to overfitting, vanishing gradients, and exploding gradients. Savior initialization and e-initialization use normal distributions with different variances to initialize weights, which can help with convergence and learning. Savior initialization is used for sigmoid, Sophax, and tan functions, while e-initialization is used for ReLU and its variants. Orthogonal initialization is another method that initializes the weight matrix to be a random orthogonal matrix, which can help with convergence and learning. Choice of initialization method depends on a specific neural network architecture and activation functions used. What is the method of initializing the weights of a neural network based on a pre-trained model on a related task, and how is it beneficial for recurrent neural networks? Answer: pre-trained initialization is a method where the weights of a neural network are initialized based on a pre-trained model on a related task. For example, the weights of a convolutional neural network can be initialized based on a pre-trained model on ImageNet. This method has been shown to work well for recurrent neural networks because it leverages the knowledge gained from the pre-trained model and helps the network to learn more efficiently. By initializing the weights in this way, the network can start with a better understanding of the task and focus on fine-tuning the weights rather than learning the basics from scratch. This can lead to faster and more accurate learning. What is fine-tuning and deep learning? Answer: fine-tuning is a technique in deep learning where a pre-trained neural network is modified to fit a new task by adjusting its weights through further training on a new dataset that is similar to the one used in the final application. This involves replacing the output layer, freezing some layers, or training only certain layers on the new task to adapt the network to the new dataset and task. The goal is to learn the important characteristics of the new task and adapt the pre-trained network to the new job and dataset. This process enables the network to learn from the new data and improve its performance on the new task. What is batch normalization and how does it help in deep learning? Answer: batch normalization is a technique used in deep learning to prevent the model from experiencing vanishing or exploding gradient descent problems. It normalizes and scales the inputs to each hidden layer by computing the mean and standard deviation of each mini-batch input and applying it to the normalization. This ensures that the distribution of inputs to each layer stays consistent throughout training, which helps the network to learn more effectively and converge faster. Additionally, batch normalization prevents vanishing or exploding gradients by ensuring the gradient is within an appropriate range, and it acts as a regularizer by reducing the need for regularization techniques like dropout layers. Overall, batch normalization helps to stabilize the training process and improve the performance of deep neural networks. What is a dropout in deep learning? Answer: dropout is a regularization technique used in deep learning to prevent overfitting. It randomly drops out or sets to 0 some of the neurons in a previously hidden layer during training, temporarily removing their contribution. This helps the network learn more robust features and prevents it from capturing noise during training. During testing, all neurons are used, and their outputs are scaled by the dropout probability to ensure consistency with training. This technique makes the network more robust and less prone to overfitting. What are convolutional neural networks, CNN? Answer: convolutional neural networks, CNN, are a type of neural network commonly used for computer vision tasks such as image processing, image classification, object detection, and segmentation tasks. They apply filters to the input image to detect patterns, edges, and textures, and then use these features to classify the image. CNN are composed of multiple layers, including convolutional, pooling, and fully connected layers, which work together to extract features from input data and make predictions or classifications. What do you mean by convolution? Answer: convolution is a mathematical operation that combines two signals or images by sliding one over the other, element-wise multiplying them, and summing the results. In the context of image processing and computer vision, convolution is used to extract features from input data by applying filters kernels to the data. This process helps to identify patterns, edges, and other relevant information in the input data, which is essential for tasks such as image recognition, object detection, and image segmentation. In CNNs, convolutional layers are used to process input images using a set of learnable filters, allowing the network to learn and extract relevant features from the input data. What is the purpose of the convolutional layer in a convolutional neural network CNN? Answer: the convolutional layer in a CNN computes the dot product between kernel weights and corresponding input image patches, which are obtained by sliding the kernel over the input image data. This process produces feature maps as the output, allowing the CNN to extract local features while preserving the spatial relationships between features in the input data. This is particularly useful in image processing, where the location of features within an image is often as important as the features themselves. The convolutional layer is an effective method for extracting features from images, enabling the CNN to learn complex patterns and relationships in the data. What is a kernel in the context of convolutional neural network CNN? Answer: kernel, also known as a filter or weight, is a small matrix used in convolutional neural network CNN to perform convolution on input data. The kernel shape is chosen based on the size of the input data and the required level of granularity for extracted features, typically being a small matrix like 3x3, 5x5, or 7x7. The kernel plays a crucial role in extracting features from the input data, allowing the network to learn and recognize patterns. What is the purpose of optimizing the kernel value during the training process and feature extraction? Answer: the purpose of optimizing the kernel value during the training process is to extract the most relevant features from the input data. The optimized kernel value is then used to apply the kernel to the input data, moving over it in a sliding window and performing element-wise multiplication and addition to create a single output value. This process helps to highlight the most important features in the data, allowing for better analysis and decision-making. What is stride in the context of convolutional neural network CNN? Answer: stride is the number of pixels or units that a kernel is moved across the input data while performing convolution operations in convolutional neural network CNN. This means that the kernel is slid over the input data in steps, where each step is equal to the stride value. For example, if the stride is 2, the kernel is moved 2 pixels at a time, resulting in a smaller output feature map. The stride is one of the hyperparameters of a CNN that can be manipulated to control the output feature map size. What is the purpose of the pooling layer in a convolutional neural network? Answer: the pooling layer is used to reduce the spatial dimensionality of the feature maps while maintaining the most important characteristics produced by the convolutional operations. It helps to reduce the size of the spatial dimensionality, making the computation faster, reducing memory usage, and preventing overfitting. Additionally, it makes the features more invariant to small translations in the input data, improving the model's robustness to changes in the input data. What are same and valid padding in convolutional neural networks, and how do they differ in their approach to preserving the spatial dimensions of input data? Answer: same padding is a technique used in convolutional neural networks to preserve the spatial dimensions of the input data by adding additional layers of zeros around the edges of the input matrix, resulting in an output feature map with the same spatial dimensions as the input. On the other hand, palette padding is a technique that does not add any extra rows or columns of pixels around the input data's edges, resulting in an output feature map that is smaller than the input data. This difference in approach is used to achieve different goals, such as preserving spatial information or reducing the size of the output feature map to improve computational efficiency. Write the formula for finding the output shape of the convolutional neural networks model. Answer: the formula for finding the output shape of a convolutional neural network CNN model is given by output equals a plus twop kw plus 1. Outpath equals I plus twop kh plus 1, where I equals number of rows and columns of the input image, kw kh equals filter kernel dimensions, sh equals strides, p equals number of padding layers. This formula calculates the output shape of the convolutional layer after applying the convolution operation, considering the padding and stride. The output shape is used to determine the size of the feature maps produced by the convolutional layer. What is data augmentation in CNN, and what are some common image transformations used in this technique? Answer: data augmentation is a technique used in deep learning to make small variations in the training dataset, allowing the model to improve its generalization ability with a greater variety of data changes. In CNNs, data augmentation is often carried out by randomly applying a series of image transformations, which can include rotation, scaling, flipping, cropping, sharing, translation, adding noise, and changing brightness or contrast. These transformations help increase the training dataset samples by creating a modified version of the original dataset, which can improve the model's performance and robustness. What do you mean by deconvolution? Answer: deconvolution is a deep learning method that reverses the process of convolution in a convolutional neural network's ENN. Instead of shrinking the output by sliding a kernel over the input, deconvolution slides the kernel over the output to generate a larger, more detailed output. This process is often used in applications like object identification, image segmentation, and image super-resolution. In image super-resolution, for example, deconvolution is used to generate a higher resolution output image from a lower resolution input image. What is the main difference between object detection and image segmentation tasks? Answer: the main difference between object detection and image segmentation tasks is that object detection involves identifying and locating specific objects within an image, typically by drawing a bounding box around the object and labeling it, whereas image segmentation involves dividing the image into multiple regions or segments, assigning a label to each pixel, and identifying the parts of the image. In other words, object detection focuses on finding specific objects, while image segmentation focuses on understanding the composition of the image. What are recurrent neural networks (RNN) and how do they work? Answer: recurrent neural networks (RNN) are a type of artificial neural network designed to work with sequential data or time series data. They are different from feed-forward neural networks because they have a loop or cycle within their architecture, which allows them to preserve information over time. This makes RNN suitable for tasks where context is important, such as natural language processing. RNN analyze input sequences one element at a time, maintaining a hidden state that contains a summary of the sequence's previous elements. The hidden state is updated at each time step based on the current input and the previous hidden state, allowing RNN to capture temporal dependencies between elements of the sequence and make predictions. The fundamental component of an RNN is the recurrent neuron, which receives the current input vector and the previous hidden state as inputs and generates a new hidden state as output. The output hidden state is then used as the input for the next recurrent neuron in the sequence. RNN can be expressed mathematically as a sequence of equations that update the hidden state at each time step, and the output of the RNN at each time step is calculated using an activation function. The learnable parameters of the RNN are optimized during backpropagation. How does the backpropagation through time work in RNN? Answer: backpropagation through time (BPTT) is a technique used to update the weights of a recurrent neural network RNN over time. It works by unfolding the RNN into a feed-forward network, where each time step is treated as a separate layer. The error is then propagated backwards through the unfolded network, adjusting the weights to minimize the loss. This process is repeated for each time step, allowing the RNN to learn from the temporal dependencies in the data and adapt its behavior accordingly. In other words, BPTT helps the RNN to learn from its past mistakes and improve its performance over time. What is the process of unrolling a recurrent neural network RNN into a feed-forward network? Answer: when a sequence of inputs and outputs is given to a recurrent neural network RNN, it is unrolled into a feed-forward network by creating a separate layer for each time step. This allows the network to process the sequence of inputs and outputs in a step-by-step manner, similar to how a feed-forward network processes a single input. Each layer in the unrolled network represents the state of the RNN at a particular time step, and the outputs from each layer are used as inputs to the next layer. This process enables the RNN to learn complex patterns and relationships in sequential data. What is the purpose of the initial hidden state in an RNN network? Answer: the initial hidden state in an RNN network is used to initialize the network with information about the previous inputs and hidden states in the sequence. This allows the network to compute the outputs and hidden states for each time step by applying the recurrent function, enabling it to learn patterns and relationships in the sequence data. The initial hidden state serves as a starting point for the network, allowing it to build upon the information from previous time steps to make predictions or take actions at each subsequent time step. What is the purpose of the network's computation in the given context? Answer: the network computes the difference between the predicted and expected outputs for each time step and adds it up across the entire series to calculate the total error or loss. This process helps the network to learn from its mistakes and improve its predictions over time. The computation is used to train the network and adjust its parameters to minimize the error and achieve better performance. How is the error propagated backwards through time in a recurrent neural network? Answer: in a recurrent neural network, the error is propagated backwards through time using a technique called backpropagation through time (BPTT). This involves applying the chain rule from the last time step to the first time step, propagating the error backwards through time. The process starts from the last time step and moves backwards in time, allowing the network to calculate the gradients of the error with respect to the weights. This is a key component of training recurrent neural networks, as it enables the network to learn from its past mistakes and improve its performance over time. What optimization algorithm is used to update the network's weights, considering gradients in a learning rate? Answer: the network's weights are updated using an optimization algorithm such as gradient descent or its variants, which takes gradients in a learning rate into account. This means that the algorithm adjusts the weights based on the gradients of the loss function with respect to the weights, and the learning rate determines the step size of each update. This process helps the network to converge to a minimum of the loss function and learn the optimal weights. What is the purpose of repeating the process of training data iteration in RNN? Answer: the purpose of repeating the process is to allow the RNN to learn and capture dependencies and patterns in sequential data. This is achieved by accumulating gradients over multiple time steps, which enables the network to update its weights and improve its performance. The process is repeated for a specified number of epochs or until convergence, ensuring that the network is thoroughly trained on the training data. What is LSTM and how does it work to address the limitations of traditional RNN? Answer: LSTM stands for long short-term memory, which is a modified version of RNN designed to address the vanishing and exploiting gradient problems that occur during traditional RNN training. LSTM selectively remembers and forgets information over multiple time steps, enabling it to capture long-term dependencies in input sequences. This is achieved through the use of a memory cell controlled by 3 gates: input gate, forget gate, and output gate. These gates regulate which information should be added, removed, or output from the memory cell. The LSTM cell consists of a cell state, hidden state, forget gate, input gate, and output gate. The forget gate removes relevant data, the input gate adds new information, and the output gate extracts important information from the cell state. This gated recurrent architecture allows LSTMs to learn long-term dependencies and make accurate predictions in sequence-based tasks. What is GRU? And how it works? Answer: GRU stands for Gated Recurrent Unit, which is a type of recurrent neural network RNN designed to process sequential data. It uses 2 gates, the reset gate R and the update gate Z, to control the flow of information and learn from temporal dependencies in the data. The reset gate determines what information to forget, while the update gate decides what new information to add. This process allows GRU to adjust its behavior and learn from the sequential data, making it a powerful tool for tasks such as natural language processing, speech recognition, and time series forecasting. GRU is similar to LSTM, but with a simpler architecture and fewer gates, making it more computationally efficient and easier to train. What is the purpose of the reset gate R in a recurrent neural network RNN, and how does it interact with the hidden state and input? Answer: the reset gate R determines which parts of the previous hidden state should be forgotten or reset. It takes the previous hidden state and the current input as inputs and outputs a value between 0 and 1 for each element of the hidden state. This value is used to decide which elements of the previous hidden state should be updated with new information from the current input. In other words, the reset gate helps to decide what information from the previous time step should be discarded and what should be retained. This is useful for RNN because it allows them to learn long-term dependencies and forget irrelevant information. The reset gate works in conjunction with the update gate to update the hidden state, and together they help the RNN to learn and remember relevant information over time. What is the purpose of the update gate Z in a GRU model, and what values does it output? Answer: the update gate Z is responsible for deciding which part of the current hidden state should be updated with the new information from the current input. It takes the previous hidden state and the current input as inputs and outputs a value between 0 and 1 for each element of the hidden state. This value determines the amount of information from the previous hidden state that should be retained or updated with the new information from the current input. In other words, the update gate Z helps to control the flow of information between the previous and current hidden states, allowing the GRU model to learn and capture long-term dependencies in the input sequence. What is an encoder-decoder network in deep learning? Answer: an encoder-decoder network is a type of neural network that can transform an input sequence into a different length and structure output sequence. It consists of 2 main parts, an encoder and a decoder. The encoder takes an input sequence, breaks it down into a fixed-length representation, and captures the essential information. The decoder then uses this representation to generate an output sequence, modifying its internal state based on the input and previously generated outputs. This network is commonly used for tasks like machine translation, text summarization, and image captioning. What is an autoencoder? Answer: an autoencoder is a type of neural network architecture used for unsupervised learning tasks such as dimensionality reduction and feature learning. It works by compressing high-dimensional input data into a low-dimensional latent representation and then reconstructing the original input data from this compressed representation. The autoencoder consists of two main parts: an encoder, which maps the input data to the latent representation, and a decoder, which maps the latent representation back to the original input space. The autoencoder is trained to minimize the difference between the original input data and the reconstructed data. This process allows the autoencoder to learn a compact and informative representation of the input data. What is a generative adversarial network (GAN)? Answer: a generative adversarial network (GAN) is a type of neural network architecture used for unsupervised learning tasks such as image synthesis and generative modeling. It consists of two neural networks, the generator and the discriminator. The generator takes random inputs and generates synthetic data, while the discriminator takes both real and synthetic data as input and predicts whether the input is real or synthetic. The goal of the generator is to create synthetic data that is identical to the input data, and the discriminator tries to distinguish between real and synthetic data. This adversarial process between the two networks allows the generator to improve its performance and generate more realistic data. What is the attention mechanism in neural networks, and how does it help in tasks like natural language processing? Answer: the attention mechanism is a type of neural network that allows the model to focus on certain areas of the input while executing a task. It does this by assigning weights to different input components, reflecting their relative value or relevance. This helps the model to concentrate on key information, capture dependencies, and understand data linkages. The attention mechanism is especially useful for tasks that require sequential or structured data, such as natural language processing, where it enables the model to selectively attend to important features or context, increasing its capacity to manage complex linkages and dependencies in the data and resulting in better overall performance. What is the transformer model? Answer: the transformer model is a type of neural network architecture that uses the attention mechanism to capture long-range dependencies and sequences, allowing it to efficiently process and generate text and achieve state-of-the-art results in various natural language processing NLP tasks. It consists of several key components, including self-attention, encoder-decoder networks, multi-head attention, positional encoding, feed-forward neural networks, layer normalization, and residual connections, which work together to enable the model to learn complex patterns and relationships in the input data. What is transfer learning? Answer: transfer learning is a machine learning approach that involves using the knowledge and understanding gained by training a model on one task to perform another related task. This approach is useful because a model trained on a large, diverse dataset may learn general characteristics that are helpful for many different tasks, and can then be modified or fine-tuned to perform a specific task with a smaller, more specific dataset. This allows the model to learn from a large dataset and then adapt to a smaller dataset, making it more efficient and effective. What is fine-tuning in the context of pre-trained models, and how does it improve their performance? Answer: fine-tuning is a technique used to adapt a pre-trained model to a new task by adjusting its weights based on a smaller dataset specific to that task. This process refines the model's performance on the new task by allowing it to learn from the new data while still leveraging the knowledge it gained from the initial large dataset. As a result, fine-tuning can significantly improve the model's performance on the new task. What is feature extraction in the context of pre-trained models, and how can it be useful? Answer: feature extraction in the context of pre-trained models involves extracting the features learned by the pre-trained model and using them as input for a new model. This can be useful when the new task involves a different input format than the original task, as the pre-trained model's features can be adapted to the new task without requiring the model to learn from scratch. This approach can save time and computational resources, and can also improve the performance of the new model by leveraging the knowledge learned by the pre-trained model. What is domain adaptation, and how does it work? Answer: domain adaptation is a technique where a pre-trained model is modified to better fit the target domain by changing its architecture or training process. This is done to improve the model's performance in the target domain, which may have different characteristics such as different data distributions of feature sets compared to the source domain where the model was initially trained. By adapting the model to the target domain, domain adaptation aims to reduce the performance gap between the model's performance on the source and target domains. This is achieved by modifying the model's parameters, adding new layers, or using different training objectives, among other techniques. The goal is to enable the model to generalize better to the target domain, even if the target domain is different from the source domain. What is multitask learning, and how does it benefit a neural network? Answer: multitask learning is a method where a single neural network is trained on multiple tasks simultaneously. This approach allows the network to learn common representations that are applicable to all tasks, which can improve its performance on each individual task. By sharing knowledge and features across tasks, the network can leverage the relationships between tasks and learn more efficient and effective representations. This can lead to better generalization and improved performance on unseen data. In essence, multitask learning enables the network to learn from multiple tasks and adapt to new situations more effectively. What is one-shot learning, and how does it differ from traditional machine learning approaches? Answer: one-shot learning is a machine learning approach that enables a model to learn from a single or a small number of samples of a new problem, leveraging information gained from previous tasks. This differs from traditional machine learning methods, which typically require a large dataset to train a model. In one-shot learning, the model is able to generalize and adapt to new information with minimal additional data, making it particularly useful for tasks where data is scarce or expensive to collect. What are distributed and parallel training and deep learning, and how do they accelerate the training process of bigger models? Answer: distributed and parallel training are techniques used in deep learning to speed up the training process of larger models by distributing the computation across multiple computing resources, such as CPU, GPUs, or machines. Distributed training involves splitting the data or model across multiple machines, while parallel training involves training multiple instances of the same model on different devices or machines. Both techniques combine the results to update the model parameters, speeding up convergence and improving performance. This allows for the training of very large models or dealing with very large datasets, significantly reducing the time needed to train deep neural networks. What are neural networks? Answer: neural networks are artificial systems that mimic the human brain's biological neural networks. They are algorithms that learn to recognize patterns in data by being exposed to various datasets and examples, without being programmed with specific rules. Instead, they derive identifying traits from the data they are fed to, allowing them to adapt to changing input and produce the best possible outcome without requiring output criteria to be redesigned. Neural networks are built on threshold logic computational models and are designed to learn and improve over time. What are the advantages of neural networks? Answer: neural networks have several advantages. They are extremely adaptable and can be used for both classification and regression problems, as well as more complex tasks. They are also scalable, allowing us to create as many layers as needed, each with its own set of neurons. This makes them particularly effective when dealing with large amounts of data. Additionally, once trained, neural networks can deliver output quickly, making them a time-effective solution. They are best suited for nonlinear data such as images, text, and other numerical values that can be transformed into numerical data. Overall, neural networks are a powerful tool for processing and analyzing complex data.